Previously, we discussed how to find the mean, median, and mode from a raw data set. Next, we will discuss how to find the center of the data when the frequency distribution is given. When data is given by the frequency distribution table, the easiest measure to compute is the mode. The mode is the midpoint or the representative of the class with the largest frequency. If there are several largest frequencies, then there are several modes. If all frequencies are the same, then we say there are no modes. Let's consider the following frequency table produced by a single value grouping. The mode is 60 because 60 has the highest frequency of 4. How to find the mean of the data set that is given by the frequency distribution table? The mean can be found by using the following formula, in which we multiply each observation by its frequency, then add them together and divide by the total. Let's consider the following frequency table again. According to the formula, we compute the mean by multiplying each observation by its frequency, adding them together, and dividing it by the total. The mean in this example is 64.1. The least trivial measure of center to find from the frequency table is the median. To find the median, we are going to use the cumulative frequencies and the following process that depends on whether the number of observations is odd or even. When n is odd, the median is the midpoint of the first class for which the cumulative frequency exceeds n-1 divided by 2. When n is even, the median is the average of the midpoint of the first class for which the cumulative frequency exceeds half of n-1, and the midpoint of the first class for which the cumulative frequency exceeds half of n. Often, these are the same midpoints. Let's consider the following frequency table again, along with its cumulative frequency table. Since n is even, we find the midpoint of the first class for which the cumulative frequency exceeds 10 divided by 2 minus 1, which is 4. And then we find the midpoint of the first class for which the cumulative frequency exceeds 10 divided by 2, which is 5. The average of the two 60s is 60. Let's consider the following frequency table produced by an interval grouping. The first thing we need to do is to replace each class with the class representative, in this case, the class midpoint. Now we're going to do the same thing as before, using the class midpoints as the data entries. So the mode is 52.5 because 52.5 is the midpoint of the class that has the highest frequency of 13. The mean is found by using the formula, and in this example, it is equal to 55.61. To find the median, we add the column with the cumulative frequency values. And since the cumulative frequency 34 is the first one that exceeds 45 minus 1 over 2, which is 22, we conclude that the median is 57.5. You may not recognize this data set, but previously we have found the measures of center of the same data given to us in this format. Let's compare the results obtained using the original data against the results that we just obtained from the frequency table. Why the answers do not match? Recall that the frequency table is created by grouping the observations into classes, which is the process that cannot be undone. So when we're using the frequency table, we essentially assume that all observations in each class are the same as the class midpoint. As a result, the numerical summaries obtained from the frequency table are only approximations of the numerical summaries obtained from the original data set. Now we know how to find the mean, median, and mode regardless of how the data is presented. If the formulas in this section don't make sense, then reconstruct the entire dataset from the frequency table and find the measures using their definitions. However, understanding the formulas simply requires an understanding of the meaning of the frequency in the frequency table and nothing more.